Right, conversion graphs, okay, they are often used to compare two different things. Currencies, for example, in terms of how many American dollars you get for British pounds and so on. Now in this case here, they tell us, right, it says the table here shows how many American dollars a bank will give for various sums of money in pounds. So if you give the bank £10, they'll give you 18 American dollars. If you give the bank £30, they'll give you $54. £40, they'll give you $72, and so on. Now, it says here to use the table on the graph paper to draw a conversion graph to change pounds into American dollars. Okay. Now, when you do a conversion graph, you're going to end up with a straight line. Okay. Because pounds appears here on the top, I'm going to put that on my horizontal axis. Okay, pounds. So you copy down exactly what's in the table on your axis of pounds and the pound symbol there, and American dollars here on my vertical axis. Okay. Now, in terms of the scale, because we need to put a scale here, the pounds goes, excuse me, all the way up to 50. Okay. Okay. So we need to have our axis going up to 50 here. So we start at 0. And if we think then, maybe going up in tens, I think it's going to work. Okay, 10, 20, 30, 40, 50. Plenty of room. Okay, we could even put 60 there. Okay, it's not needed, but we could put that there in our scale. Right? American dollars then, if you notice on the table, that goes up to 90. Now, let's see, will that actually work for us if we go up in tens? 10, 20, 30, 40, 50, 60, 70. It doesn't it? When it goes up to 70, we have to go all the way up to 90. So it doesn't fit in. So I'm going to instead of going up in tens, I think I'm going to have to go up in 20s. So 20, 40, 60, 80, and I need to get to 90 tonight. So one more will give me 100. That will fit in then nicely. Okay, you could even put 120 there if you wanted to. Okay, so let's use these values now and plot these points on the graph, right? Now we think of these as coordinates. So £10 gives you 18 American dollars. So if I go across to £10, I need to go up to 18. Okay, now 18 here, this scale of course is different, isn't it? Because we've got 10 squares here, which would take us to 20. Okay, I mean halfway there is 10, isn't it? Think about what each little square represents. Okay, if we sort of zoom in there for a minute. Alright, each little square, there's 5 squares, isn't there? That takes you to 10. So each little square will be worth 2, won't it? Because if you divide 10 by 5 squares, 10 divided by 5 is 2. So each little square is 2. So in terms of 18, we'll have 12, 14, 16, 18. 18 will be there, won't it? Okay, 18 will be there. So each little square represents 2. So 2 from 20, isn't it? Gives you 18. So I think if we're going 1 square down, it represents 2. So we've got 18 there. So yeah, £10 will be 18. So I can put a little cross there. Okay, let's zoom back out again. The next measurement then, we had £30 is 54 American dollars. So I go across to 30, all the way up to 54. So 50 is there. Okay, 54 then, well, going up, that's 52, that'll be 54 there. £40 is $72, so across to 40, up to 70 is there, so 72 is here, so mark that. And then £50 is $90, so across to 50, up to 90, which is here. Okay, now these points should line up, right? If they line up, then you know you've done your graph properly. Okay, so get your ruler, okay, now and make sure they do line up. And they do, don't they? If you can notice here, every one of my points lies on that ruler nicely. Okay, so once they've lined up properly, okay, not only do you join the points up, you need a line that goes through the whole graph paper, okay? It's got to go through the whole graph paper, all the way to the end. Alright? Goes through the origin, right? Often it goes through the origin. It goes through 0 here. It doesn't always go through 0 though, okay? It doesn't always go through it, so, you know, it doesn't have to go through here. The main thing is these points are lined up. So we've got a conversion graph. It is a straight line and we can use it. We can use it to convert any amount of values, any amount of currency. So it says here, use your graph to convert £24 into dollars. All you've got to do now, £24, well, if we go to the pounds axis, 24 is here, isn't it? That's what 24 is. So what I'm going to do, I'm going to use my graph to work out what that is in dollars. So I go up from 24, okay, go up from 24 until I hit the graph. I hit the graph there, okay, so then I'm going to read across from here. So you can draw this line in your graph, no problem at all. You go up from 24 all the way up till you hit the graph. You read across, okay, to see what that is, and it's 1 square up from 40, so that'll be 42. So 42 US dollars. Move on to the question. I'll use the graph for the question. All right, question 2. It says here now, use the graph paper below to draw a conversion graph between Celsius and Fahrenheit. Okay, so two ways of measuring temperature, Celsius and Fahrenheit. They relate to each other. We can draw a conversion graph for it. Okay, so in this case now, if we look at our table up here, it says minus 5 degrees Celsius is 23 degrees Fahrenheit. So our axes have already been drawn for us. Okay, here's our Celsius. You've got to go to minus 5 degrees Celsius, and it says in the table that that's 23 Fahrenheit. So minus 5 Celsius, you go all the way up then to 23 Fahrenheit, which is here. Put a little cross there. Okay, a little dot. Next one then, 5 degrees Celsius is 41 Fahrenheit. So you go across to 5 degrees Celsius up to 41, which is here. Okay, little dot or little cross. And then the last one then, 25 Celsius is 77 Fahrenheit. So I go across to 25 Celsius, and that's 77 Fahrenheit, which is all the way up here. Okay. Okay, so you draw then your conversion graph, and it goes through each of the points. Okay, it should go through all of the points. Okay, and you draw your line through the 3 points. So then you've got your conversion graph. By the way, I'm using a pen, of course, so that it's clear on the camera. You need to be using a pencil always. Okay, when it comes to graph paper. Okay, when it comes to drawing graphs. So we've done our conversion graph. If we look now at part B, it says water freezes at 0 degrees Celsius under normal conditions. Okay, so you might know that already from your science lessons. The water freezes at 0 degrees Celsius. Use your graph to find the temperature in Fahrenheit at which the water freezes under normal conditions. So 0 degrees Fahrenheit is here. Okay, here. All you've got to do is go up to the graph to see where your Fahrenheit is at 0. So the line's already drawn for you because it's the axis. And if we look up here, it's that point there, which is 32. Okay, so 32 degrees Fahrenheit. Part C then, it says, which is the higher temperature, 60 degrees Fahrenheit or 18 degrees Celsius? You must give a reason for your answer. Now what I would do is, so you want to work out what's the highest, 60 Fahrenheit or 18 degrees Celsius. What I would do is, I would have a look at what 60 degrees Fahrenheit is on my graph. Okay, so if you look here at 60 degrees Fahrenheit, okay, here's 60 degrees Fahrenheit. Let's see what that is in Celsius. So 60 degrees Fahrenheit, let's draw a line across until it hits the graph. Okay, it hits the graph there. Let's now draw a line down. Okay, from the graph, make sure your line is vertical. Okay. Okay, so at 60 degrees Fahrenheit, we can see what this is in Celsius. If I go down here, okay, I've got that measurement there. Now that is 1 square after 15. Now I think with the scale, every 2 squares represents 1. So you know you've got, this is 16 here, okay, and then you've got 17, 18, 19. So if it's between 15 and 16, it's 15.5, isn't it? So we've shown here in our graph that 60 degrees Fahrenheit is 15.5 degrees. 60 degrees Fahrenheit. I hope that makes sense to you, just using my conversion graph there. As I said, going back to it, 60 degrees Fahrenheit is 15.5 degrees Celsius. Okay, so which is higher? You know, it says which is higher. Well, clearly, if 60 degrees is 15.5 degrees Celsius, that's got to be higher, isn't it? 18 degrees Celsius is higher. Okay. Right, question 3. Martin prefers to measure distances in kilometres rather than miles. The table below shows the number of miles and the number of kilometres for each of 3 distances. So here we've got miles compared to kilometres, and you know 5 miles is 8 kilometres. Okay, that's the sort of conversion we usually use. 5 miles is worth 8 kilometres, and here then we've got different rates. It's been scaled up. 30 miles would be 48 kilometres. 42.5 miles would be 68 kilometres. Use the data in the table to draw a conversion graph. Okay, now when we look at our conversion graph, miles, the axis has been given to us. Okay, goes up to 50. All right, so what we need, isn't it? If we go back to the table, miles needed to go up to 50 here. Because 42.5 is our highest one. Kilometres is 68. So let's see if we can also go up in tens with kilometres. So, you know, 10, 20, 30, 40, 50, 60, 70, it fits in nicely. So that'll be 10 there, 20, 30, 40, 50, 60, 70. Okay, so remember now from the tables, show you back here, 5 miles is 8 kilometres. So 5 miles, so go across the 5 up to 8, which is there. So mark that there, okay, with a dot. Then the next one, what was it? 30 miles is 48 kilometres. So 30 miles is here, all the way up to 48, which is up here. Okay. So we've got 2 points now. 30 miles is 48 kilometres. And then the last point then, 42.5 miles is 68 kilometres. So 42.5, well, 42 is there. 42.5 will be in the middle between the next 2 squares, and that's 68 kilometres. So we're looking at here. Okay, so I've got 3 points. Okay, all I need to do now is join these up. Okay, get my ruler, line them up. Okay, and in this case, of course, it will go through the origin, won't it? Because if you think about it, 0 miles is also 0 kilometres, so that has to go through there. But remember now, with your conversion graph, it's got to go through the whole graph paper there. Okay, and I've used my 3 points they've given me. Now part B, it says, or part 2, it says the distance between Martin's house and his favourite bicycle shop is 70 miles. Okay, explain how you can use the graph to find this distance in kilometres, and then complete the sentence. 70 miles is approximately a certain amount of kilometres. Now 70 miles, let's have a look here on our axes. Okay, of course there's a bit of a problem here, isn't there? Because we want, you know, this question clearly says that the distance between the shop and his house is 70 miles, but my graph only goes up to 50 miles. My axis only goes up to 50 miles there. So we've got to think, how am I going to get 70 miles? Now one way of doing it is to actually look at a value lower down and then try and scale it up to 70. Okay, so let's try and think of a value that goes into 70 nicely. Okay, there's lots of values that go into 70. 10 goes into 70. The one I'm thinking of at the moment is 35. 35 goes into 70, isn't it? So let's have a look at what the reading is at 35. Okay, right, it might not make much sense what I'm doing in a minute, but follow me on it and then you'll see what's going on. So 35 miles, let's see what that is in kilometres. Okay, so go from 35 miles, okay, on the miles axis, and draw a vertical line up until you hit the graph, and then let's read across. Okay, let's read across what that is. So from going horizontally then, from your graph, we've got this here. So 35 miles is 56, isn't it? That's 56 there, that is. Okay, so 35 miles is 56 kilometers. Okay, now what's great about this is, because we know from our graph that 35 miles is 56 kilometers, to get 70 miles, you just need to scale it up. Okay, in other words, ask yourself, what do I do to 35 to get to 70? Well, we just need to double it, don't we? Okay, if we double 35 miles, we get 70 miles. It's the same then with this. Obviously, we need to double this. Okay, so if you're doubling the miles, you've got to double the kilometers as well. So double 56 is 112. Okay, so 70 miles is approximately 112 kilometers.